if there is a problem, then you can WhatsApp me.
Sure.
Yeah.
Absolutely.
Yeah.
And if you just
Yeah,
keep
but
your
what
video off, everybody,
one
because
video isn't going to make a difference. It's just, it's if everyone has their video on, you're going to have a problem. So
yeah.
you could keep your video on without issue.
Yeah, wow, okay, I don't know. Anyway, doesn't matter.
Okay.
Okay, so I will now start presenting. And Anandji, if you start the recording, that's good. And Priyanjan, if you just admit everybody, yes, whoever comes through, so that I will not have to come back. Yes? Okay,
Yes, will do.
good. Thank you very much. Welcome, everybody. First of all, just some housekeeping things. I have shared you the videos from last time. You should now be able to access them. We have removed all restrictions. That means that anybody can see those videos. And because we are not promoting it anyway, so all that is good. So you are able to access the videos now. And today, again, we'll proceed in the same way. We'll continue deeper into the same, into the code, look at the scikit-learn notebook. Some of you said that you needed to understand that. And this is the good time to look at the scikit-learn notebooks because we can look at them in the context of the regression. I will also start off about speaking about which algorithm to apply where, because this was a question a lot of people of you had asked. And this is the immediate thing I'm going to start now. The link I'm going to share with you, rather from which this is derived, the deck is derived, is from McKinsey. It's quite a good source, but it might be a little bit outdated because things change very fast in AI, but still it's a good sort of a landscape or good way to think about the problem, and be aware that things change. Before I start this thing, I would like to say two important points about when to choose an algorithm. The first point is that historically what happens is you start with the benchmark, and then you try to improve the benchmark with multiple algorithms. So for example, if I'm doing classification, I do a basic classifier first, the simplest one, SVC or something like that, and I continue to try other algorithms on top of it, and then try to sort of combine the results of that. This is something which is very common, and we'll see subsequently as well. The second point is this whole thing about automated machine learning. So there's a trend at the moment which combines, if you Google the word auto ML or automated machine learning, so a number of techniques, a number of libraries, a number of platforms allow you to combine multiple algorithms as a part of their whole process. H2O.ai does that, Data Robot does that. These are very expensive products, but even in scikit-learn you can do that, in Google Cloud you can do that, in AWS you can do that, in Azure you can do that. So I think that what I'm trying to say to you is that in reality, things are not exactly clear cut as which algorithm to use where. So this is the sort of the practical experience of having to work with that. So the way I teach it in Oxford is similar to sort of ways we will look at the classification one, which we only started the regression yet. And now I'm actually going back to scikit-learn. The reason I'm going to do that, or Aisha is going to do that today, is because once you set your foundations right with the regression, you can easily apply the same thing to classification as well, because there also you got hyperparameter tuning, you got normalization, all those things are there as well. So once you understand that once, you can apply them into other areas as well. So this is why we're trying to spend such a lot of time here. In terms of the scope of this course, what I want to cover is two machine learning algorithms and two deep learning algorithms. So the first one is first one is regression, which is what we are doing, the first notebook. The second notebook will be classification, which will be the next notebook from here. And the last two notebooks are deep learning algorithms. One is MLP, multi-layer perceptrons, and the other is CNNs, which is convolutional neural networks, which is used for image-based data. So in this way, you will cover two machine learning and two deep learning algorithms, and that in 90% of the cases will cover most of the AI type requirements within that, because the requirements come within those areas. Now, of course, that doesn't cover much more complicated things, some of which you guys have been asking about, like GANs, reinforcement learning, that type of stuff, which is really where we spend a lot of my time doing. But normally people don't tend to spend a lot of time with that type of stuff, mainly because those algorithms tend to be more complicated, more research oriented. even I wouldn't even say I mean, if you look at a bank, for example, would be using a classic classification like XGBoost or something like that. Any more, those are the classic algorithms which people will use. Kaggle competitions, they use XGBoost as well. So that's what I'm trying to say to you, that the reality of how things work will be quite different um, from sort of explaining it from first principles as we are trying to do. But it is very important to explain from first principles, because then you start to see what's around, and then you can start to get in there and do your work with that. So I'm going to present you literally the questions of somebody asked before. I think Farid also asked in the chat, was which algorithm to use when, and that's going to be the discussion. But I want to caveat that with this discussion I just had with you, because this is I mean, I just want to let you know that the real life is not exactly as clean cut as this. Now, any question, and also I wanted to emphasize to you again, few people have just joined recently, to say that in this course, we are going to cover 2 machine learning algorithms and 2 deep learning algorithms in a lot of detail. So we're going to cover regression. Today, we are going to go back to the scikit-learn notebooks. If you remember right at the beginning, I shared with you 4 notebooks that Aisha shared with you: pandas, numpy, matplotlib, and scikit-learn. Now, the pandas is very easy because they just matrix multiply, basically made the basic sort of data set processing. Matplotlib is also quite easy because it is just visualization. Um, NumPy is basically matrix manipulation. Again, if you read it a little bit, you should be fine with that notebook and some Googling around. The scikit-learn is quite different and quite difficult, relatively speaking. So, and some of you also had posted this question before, that they found the scikit-learn quite hard. And this is now a good time to go back to scikit-learn, because at this point you're seeing regression, you're seeing some of those things like grid search and so on being used here. And I'm hoping that I cover enough of the grid search for you now in the theory, so that we can go back and look into that with that. So that is my goal for today. So over the next 2 hours, I want to cover which algorithm to apply when, and then to apply some of those areas like hyperparameter tuning before I should then takes over the same thing in code. Okay, any questions on this so far before I go? Now, there is a issue about unmuting people today for some bizarre reason. If you are not able to unmute yourself, you can post it in the chat, and I will look at. So Parag cannot unmute yourself. Shreya can unmute herself now. So any questions on this so far? If you want to post in chat or unmute yourself and speak, that's perfect. If not, then I'll start presenting. Basically, I'll wait for just a minute to see if anybody's got a question so far. Yes.
Yes, Professor, this is Prashant here.
Yeah. Hi.
So, yeah, thank you for the details. So, I just want to know, when we talk about AI or machine learning,
Yeah.
okay, so if we compare anything like any language like C, so we
Yeah.
have 6, 7 areas, major areas like data type, loops, data
Uh-huh.
structures,
Uh-huh.
pointers, and
Mhm.
so like this one. So, if you know these types of area, then you can say you know C
Uh-huh.
language, for
Mhm.
example. So
Mhm.
if we consider like AI subject, it is of course descriptive. Then
Mhm.
what are the main bullet points that we should touch? That okay, we should means that we can say okay, we know some part of AI, and then we can study further on that. So just
Yeah,
bullet
that's a
point.
good question. So basically, the 2 notebooks we are going to show you, rather
Hmm,
all the 4 notebooks,
hmm,
they will have a certain pattern, and those are the ones you need to know. I mean, for example, the fit algorithm, the predict more one function, and so on and so forth. So what you must remember is that anything with machine learning or deep learning is a language, and there are some functions specifically for that. So for example, Python is a general purpose language. You can use
hmm,
Python with Django and everything like this.
right.
Outside of machine learning, within, when
Hmm,
it used in machine learning, it has a series of functions or libraries which tend to be used there, and the 4 libraries are the 4 ones we talked about,
hmm,
and within that, all of the ones we are covering with that, so like grid search and so on and so forth. So if you know all of those things, then it's a good way of saying that you understand machine learning or deep learning. With deep learning, there are some more things, and they include basically things such as um, the Keras library, which we haven't discussed so far. Keras, Keras, TensorFlow and Keras. So you can either use that or PyTorch. So we are using TensorFlow, and we will be talking about the Keras library with that. So that basically summarizes that. I hope that answers your question. Okay.
Yeah.
Cool.
Thank you.
Thanks. Yes. Okay, cool. So I'll start presenting now in the interests of sort of keeping up
Hi,
with
Ajit.
time. Yeah, sorry. Yeah. Go ahead.
Yeah, just a couple of quick questions. Last time you had agreed to share some material on transformers to me and the other lady, so just a gentle reminder on that. Uh,
Yes, yes, thank you for reminding me. I will make a note of this because I will tend to forget. Wait a minute.
Thanks,
Okay,
Ajit.
and what
And
else?
the other thing is I posted a question on Slack last time. It's still unanswered, but I just wanted to maybe say it out loud here. We covered regression last time, right? And we saw that sklearn, basically we covered the SVR.
Mm-hmm.
Uh, but
Yeah.
then basically sklearn also has linear regression function, which is a simple linear regression. But what I searched in that SVR is basically a part of the support vector regression. So any particular reason why we took support vector regression instead of simple linear regression? Because in linear regression, we can actually get the slope and the intercept, which is again a question that somebody else had asked, whereas in SVR, we cannot get that. So,
Yeah, so traditionally there are a number of ways to do these things. One of the reasons why people like SVR is because there is a sub SVC is very common. So support vector classification is very common within support vector. SVM, support vector machine, is common, but there is no particular reason as such. And in fact, I would encourage you. One of our ideas was to actually get you to try linear regression and an algorithm. So this was one of the exercises we wanted to give you basically at some point. So it's worthwhile thinking about this, because in the end, when you have to apply another algorithm, you have to understand how it works, and then apply that by looking at the library. So our goal was to treat you with one and get you to apply another one, and that's the plan. But anyway, so this is what I wanted to say. There was no particular reason, but this was one of the reasons. Cool. Okay.
yeah, thanks, Ajit.
Cool. Thanks. Yeah. Okay, good. So now I'll start presenting here, and then we go from here. So let me start this before. So window. Okay. So now I'm going to cover the same one we talked about before. And then I'm going to basically discuss this particular question, which is adapted from McKinsey, and what it tries to talk to you is which algorithm to apply where. So this was the question people had asked, and I sort of caveated that. And the point I'm trying to make here is that all these algorithms are probabilistic, meaning that they are never going to be 100% correct, and that there is the whole descriptive piece which is outside of algorithms, correct? So because if you look at the flow of it, then you do the descriptive learning and then you go to the predictive side. So you do the descriptive learning to understand the data, and then you go to the predictive to apply the algorithm. So what happens, just to recap a couple of things. Supervised learning we talked about is when you train it with some label data, and typically that is used under a number of examples, and in majority of the cases they will be labeled data. So for example, it's about sort of understanding house prices, which we are looking at, or trying to understand if you have a disease or not, that type of stuff. Then unsupervised learning is when you do not have a label for it, and this includes a number of patterns within the core data. So things such as clustering is unsupervised learning within that. And basically how it works is that it tries to infer the structure from the data by trying to understand a distance metric between the data points. And that's how clustering works. Sort of it tries to clump, so to speak, things which are similar to each other in that, and so that tries to categorize them. Then there is reinforcement learning. So reinforcement learning is the one which we won't cover, but I wanted to just cover this here to say that It's a key algorithm. It's in the news a lot because of what Google does. So there was news about 2 weeks ago when Google used reinforcement learning to understand the behavior of a nuclear fusion reactor. And it's used in these complicated cases like predicting the weather and things like that. It mostly learns by trial and error. It's an algorithm we use very much in Oxford, and we have very good kind of links with sort of developing this, but it has one big disadvantage, that it needs a lot of trial and error data to make it work, and therefore it's sort of hard to apply it into many situations, and this is one of the key problems with it. And as I said to you, it works by trial and error. That's why you can use it in a game-like scenario where there is the cost of the error is very low. But if you use it in production with some sort of a machine or some sort of a factory, where of course mistakes are very high, this is the main problem with it. And that's why you need to understand when to apply it. Now here we come to these supervised learning business cases. Linear regression. When do people understand linear regression, use linear regression? It's obviously used for understanding a point in time data. So for example, finding out advertising rates, that type of stuff. Yes, house prices, advertising rates, and so on. Trying to find a number in the future with that. So this is the characteristic of linear regression. Logistic regression, although the term regression appears in logistic regression, logistic regression is a classifier. It's a probabilistic classifier, and it is mostly used into simple things such as trying to understand whether something is malignant or not. One other very important point you must remember is that these are things have evolved over time, correct? So historically, logistic regression was very common. Today, that's not the only choice, correct? Because you've got so many other ways to do a classifier, and that's what's happening today. So you have a lot of choice, a lot of areas to do these classifications, and that's what you will have to do. Then you have something called linear discriminant analysis. So basically, it's an upgrade to logistic regression to deal with non-linear problems. So traditionally, non-linear data is not easy to do. By linear classifiers, you mean that you can do either a line or a plane between the points. If they are non-linear data, non-linear separation, it is not easy to do this. Of course, it is easier with deep learning, and that is one of the big algorithms currently with non-linear classifiers within there. But this is another algorithm which is used for that. Then, of course, you have decision trees, which are very interpretable. That is why they are very common. They help you in many different cases whenever there is a classifier of some kind. Then there is naive Bayes, which is a technique which uses the Bayes theorem, and again it is using some sentiment analysis, spam filters, etc. Support vector machine, very common algorithm. Um, Again, used in many classifier problems, and these are some examples on that, online advertisements, so on. Random forest is another classifier which is again used historically, predict call volumes, predict electrical surges and distribution grids, and so on. Again, this is why I started off with a caveat that not all of these are exactly applicable all the time, because as I said to you, things have changed, things have evolved, and it's not necessarily the way it would apply it in real life, but these are some examples of that. Then there are algorithms like EdaBoost. I haven't heard much people using this, but it's sort of used in the fraudulent detection of credit card data. Gradient boost in trees, which is use another algorithm which predicts sort of inventory levels and so on. So what you are seeing here is things are evolving even here. So for example, you saw decision trees here somewhere before. This is a decision tree, and then this is something called gradient boosted decision tree. So it's sort of the algorithm itself has evolved. I'm not saying that this is the right way to do it, it again comes back to my caveat I started at the beginning. Then you have a simple neural network, which is a straightforward neural network with a minimum number of layers, which is 3. And even that works as a classifier. You can use it as a classifier as well. And then you have a whole bunch of unsupervised learning algorithms. So when you have unsupervised learning, you have k-means, which is simple clustering that can be used to predict churn, that type of stuff. Gaussian mixed models, GMM. So this is a more generalized form of k-means. It's another form of clustering within there. Then you have hierarchical clustering, which is the sort of split and aggregates around a hierarchical tree. So it's clustering with the hierarchy. And then you have recommender systems, which talk about recommendation systems, which basically is what you see in Amazon. And there's a whole bunch of algorithms around that. They are a bit more specialized, but you can Google them and find them out with that. And then there are reinforcement learning. Reinforcement learning has a whole bunch of cases which are very unpredictable. For example, using the inventory, using inventory management, robot movement, self-driving cars, training, online auctions, that type of stuff. So highly valuable, but also very hard to do. Not only from the algorithmic point of view, but from the point of view of expense in terms of the computation power and expense in terms of the data which you're likely to work with. Now we come to deep learning. We've kind of covered this before, but I will go with this a little bit more before I take some more questions. So coming back to deep learning, what is deep learning? Just to recap, and I said to you, deep is that the idea that you have a deep neural network. When I said deep, I mean that it has many layers in the neural network, and what it then tries to do is build up a representation. I talked to you about this picture of the woman, where you build this representation bottom up. This is the characteristic of deep learning, so that you do not have to tell it what features to use. It tends to detect what those features are, which is why I use the definition automatic feature detection or representation learning, and that's the same thing within that. Now, there are 3 main classes of deep learning algorithms. The first one is multi-layer perceptron, which is actually not on the screen, but it is the same thing which I talked to you, which is the traditional deep learning neural network, correct? So it's a straightforward neural network, which you basically apply data, and you get some result with that through a deep learning neural network. There are 2 variants of that. The first one is called convolutional neural network, which we will be looking at in this course. And then there is the recurrent neural network, which is to do with sequences. Convolutional neural network has to do with images. And recurrent neural network has to do with sequences. And when I say sequences, I also mean lots of text. Yes, so text is a sequence, and so on. So there's a whole bunch of interest around text at the moment, and a whole area around natural language processing has evolved, and that's where the transformers world is going, basically. So while I'm talking to you about recurrent neural network as an algorithm, it's again useful, but you must put it in context today that if you look at text as a sequence, this is one of the hottest areas in deep learning, and there is a whole group of languages called natural language processing, and then there is the whole transformers world, which is sort of built around natural language processing within that, and that involves things such as transfer learning and so on and so forth. So then that becomes quite complicated. However, more purely sort of network point of view, sort of purely understanding point of view, historically there are 3 key algorithms when it comes to deep learning. The first one is MLP, multi-layer perceptron, which is what we saw before. The other one is convolutional neural network, which is to do with images, and the third one is recurrent neural network, which is to do with sequences. And of course, the first 2 we are going to cover in this course within that. Convolutional neural network, what is it? The main thing is that it is a multi-layer perceptron with a specific set of characteristics, which I will be discussing with you in a separate set of slides. So I won't discuss this in great detail now, just to let you know that it is being used. When to use it, it is typically used for image detection. And that's what its main goal is, and we will discuss this in a separate set of slides because you need to understand some more ideas with that before jumping into that. And I don't want to start it today because I want to cover the hyperparameter stuff today, because I should then will have a background to kind of work with that. The business case for that, because this image is everything to do from detecting logos to detecting scans of patients, basically a COVID scan or stuff like that. All of that would use a convolutional neural network within that. The recurrent neural network has to do with sequences. Anything is a sequence, and sequences are very interesting for AI. Genomic sequences, language, text, that type of stuff, anything which comes as a very long sequence of things. And the main characteristic of a sequence is that it is dependent on what happened before it. So if you look at data traditionally, there is no correlation in time. Yes, because correlation in time is very important, because if I say the word, I am in London and the weather today is, and that is likely that because I am in London, the weather today is cold or rainy or stuff like that, correct? Because what went before, like when I said I am in London, then the weather today is what is likely, it's very likely, more likely to be rainy than something else. Or if I say I'm in London, it's July and the weather today is likely to be, in that case, is likely to be warm, because even in London in July, you have pretty warm weather. So this is what I mean by when you have a sequence, what happened before, what came before is relevant to what you're trying to say, or rather we're trying to predict. Which is not the case with images, for example. Yes, so I'm trying to detect a pictures of cats. It doesn't matter whether you have cat 1, cat 2, cat 3. Cat 3 may be completely unrelated to cat 2. Um, Everything is a distinct piece of information to be processed in that way. But in sequence, that's not the case, and that's what I'm trying to say here with that. And of course, you use sequences whenever there is a time series, or in any form of text. The biggest use nowadays is text. And this is how recurrent neural networks work, and so on and so forth with that. Okay, good. So this finishes that, and I wanted to share this with you first. I will take some questions here now, because the next thing I want to share with you is quite important and will take us some time to kind of go through with that. So let me take some questions here first. Okay, so now I see something in the chat before people raise their hand. Let me do this first. Okay, okay, so people can unmute themselves, which is great. So Sonal, you have raised your hand. I'll just come back to you in a minute. Let me just check these questions here first. So Raj, so an algorithm on machine learning is a process of computer transfer input data to input. Simple concept, and yet every piece of technology you touch involves many algorithms. Maybe next time you grab your phone. Yes, this is true. So there is a, so each of those things have many things, many algorithms behind it, and this is becoming far more mainstream now. Everything from Siri to facial detection to sort of all of these things are based on algorithms. This is why people tend to get a bit concerned about how exactly are these algorithms being governed or developed and so on, something like that. But yes, I mean, the world is very much driven by algorithms, and this will go along with that. So have I shared this slide? Yes, this is the same one from last time, Shreya. The only thing is I hadn't completed this section from last time, which now I'm completing. I have shared another slide on the Slack, which I'm going to cover now after this one, because but the slide I shared with you now is the one I already covered before, and everything is in the resources channel, as Saif has pointed out as well, because that's what I'm keeping. And by the way, Aisha has shared something as well, which she's going to cover as well. So the both of us will continue to share with that. At the moment, neither Marina or Kauthar are sharing much. Kauthar you saw on the first time, but Marina definitely will be with us in the future, with possibly around the deep learning or unsupervised learning with that. Very good. Okay, so now Sonal, yes, please. Yeah.
Thanks. So my question is, when we are talking about RNN and sequences from text,
Mhm.
detecting something like sarcasm in a speech, it's kind of undefined. We cannot really tag that. Will that be a good candidate for RNN or reinforced learning?
Okay, good question. Um, the first thing is sarcasm or anything like that is in most cases a supervised learning problem, because actually if you look at text, for example, yes, so there is lots of text where there is a lot of text which has got sarcasm in it. And when I'm not talking about text as in recorded text. You can even take Shakespeare's work, for example, yes. You can look at Shakespeare, you can look at Twitter feeds, you can look at Google, you can Google things and so on and so forth. The point is that I can create a body of data which has got sarcasm built into it, and I can write a natural language processor which can detect sarcasm, or it can detect I mean, there is even things which detect suicidal tendencies and stuff like that. So it's not just sarcasm. There are some papers on this sort of thing as well. When people are depressed, or people are likely to self-harm and things like this. So this is all these things are possible. So my answer to that question is it is definitely a supervised learning problem, and also it is relatively easy to detect, and in the normal circumstances it is not a reinforcement learning problem. However, there are cases when you could use reinforcement learning for that, and I mentioned to you last time that we are working on a paper called to detect cognitive dissonance. Cognitive dissonance is the main problem with that is, so cognitive dissonance is the concept where people are conflicted as opposed to lying. Yes, so lying is quite easy to detect. If I am trying to detect from either speech or from text if somebody is not telling the truth, then that's relatively easy to detect, because that's a supervised learning problem. If you've got enough examples of people lying or telling the truth, you can train your algorithm accordingly. But cognitive dissonance is conflicted and the propensity to change your action. So for example, I say to you that if you are a smoker, uh, you then justify your behavior of smoking. So for example, you can say that I am a smoker, however I saw this guy who won the Olympic prize and a gold medal and he was a smoker, therefore I then believe that smoking is not bad for me. Now, this is a very different problem because it is a problem on which there is a propensity to change your behavior. It's also a sequence-based problem because you can sort of look at a sequence in time and you can say that. So in that case, you could either we are using reinforcement learning as a way to do that, or you can use just an RNN to predict the behavior. I hope that answers your question, Sonu. It's a longer answer, but I hope that it is good.
Yes, it
Okay,
does. Thank you very
thanks.
much.
Okay, thanks. So two more people have raised their hand. Again, I will keep the interaction going quite much because I think that's the value. So Abhinav, yeah, and then Farid after that. Yeah.
Yeah. So nowadays a lot of traction is going on in the document data extraction space,
Uh-huh,
where people claim that they are using machine learning to extract key value fields from structured to semi-structured to unstructured documents,
uh-huh,
and they claim that they are using deep learning to solve the problem,
yeah.
basically, right?
Uh-huh.
So if you can throw some light as to which exact algorithms would they be using, like is it RNN because it's text, around text, or is it something else that they
Yeah, it is.
claim?
It could be RNN, but the main body of algorithms is they come under natural language processing (NLP), and they even within NLP there are two sort of how shall we say, two main ways of looking at it. The first one is when you train a body of data using all sorts of things. For example, I mentioned to you, you can even look at historical data and so on and so forth. And from that, you can understand the structure of something. Or if you've got a form, for example, yes, you got a form and you want to upload the form and try to extract something from there. For example, you got invoice data and you want to understand the behavior of the invoice. You want to understand the structure of the invoice data so that you can find out from the invoice data the pricing. Correct. So this structure can be easily trained using some form of natural language processing, some form of computer vision, that type of stuff. So again, it's multiple algorithms coming together. But the real sort of benefit in natural language processing has been what has been effectively the transformer models. So the transformer models are in general transfer learning, generally build depend on pre-built data. So what that means is that there is a large corpus of data which is pre-trained, and from that it learns it, and so it doesn't have to rebuild the whole thing from scratch. And that is a very, very powerful technique, because that's what's sort of driving the GPT. So this weekend in Oxford we had GPT-3. So we actually had a real demonstration of GPT-3. So in that case we had actually a liberal arts team who are using GPT-3 as as a collaborator to create their characters. So for example, I'm writing a Netflix script. So this was literally a group of people writing something like that. And they've been using, they then talked about creating this sort of a virtual AI character who has effectively a mind of their own and is able to then talk about something in that way. So so that's the long answer to your question. So is that okay, Abhinav? Yeah,
Yeah, thank you.
I think it is. Yeah, good. Okay, I think you're muted again. Maybe you can't unmute yourself. I'm not sure because of this problem, but I hope that's okay. Yeah. So Farid, yes, please. Yeah.
My question is a lot more basic. So with any data set, you're trying to fit it to a particular model.
Yeah.
So what's the basis for example, choosing a linear regression model over, for example, a non-linear model? Is it just the error metric, or is there a more formal pre-processing process that you deploy?
Okay, so that question is slightly different from the previous ones which we were talking about. So what you're talking about here is whether the data has a linear or a non-linear characteristic. And the way you do that is through a lot of the initial data descriptive analysis, and much of the things we are seeing either in the correlation or matplotlib and so on and so forth, on which you would determine what is the characteristic of the data. Is that something which is linearly separable or not? There is one question which somebody had asked. I don't know who this was. I think it was Sona Shreya. I think it was, but I'm not sure. And this was about the types of linear regression. Yes. So if you have a non-linear class, basically a linear regression, which is, a non-linear regression, then you have to have different ways of solving it. And those tend to be what are called the GLM, or generalized linear models, and so on and so forth. In many cases, what they tend to do is they tend to transform the non-linear data into some form of linear separable within that. So again, this is something I'm going to cover later on, but the short answer to your question, Farid, is that you basically explore the data and try to find out the characteristics of the data before you apply the algorithm. If it is highly non-linear, then you are not likely to apply a linear algorithm to it. And that's the sort of answer you would try to work with that. Okay.
Thank you.
Cool, thanks. So comment from Nitin Malik, which says that even convolutional neural network has been used to extract fields from, let's say, an invoice. Correct. Yeah, that's right. So I think many of these things, there are multiple ways to do them. And one of them is that if I have an invoice, I can literally scan the invoice and do something with that. So it may not be a sequence problem, but it might be an image problem, as Nitin is rightly pointing out, and that I agree with that. Okay, so Shreya, you've raised your hand. Yeah.
Yes, sir. So is it like when you're talking about the non-linear regression model? So in that
Yeah.
case, it's like, I mean, how will I decide? Is it like a plotting a data and just finding out the regression line? I mean, how can I come to a conclusion? It's a linear one or it's a non-linear one?
I will come back to you now. My goal was to actually cover this in another set of slides because it gets a little bit complicated to explain this. But let me come back to you on that. So I will take this as a question to come back subsequently at some point. Okay.
Okay.
Okay, because because it is not possible to explain this idea without explaining a few other ideas from there, and that I think will take us away from this discussion at the moment. So transformers was the other question we had, which was asked before, and SVM and SVR that we covered. Okay, cool. Okay, good. So I guess there are no more questions now. So I will proceed now with what I wanted to cover, which is uh, to do with. Oh, sorry. There was a comment from Raj that with the advent of modern advanced deep learning has led to significant protection. Yeah, so there are a few areas of deep learning which are advancing faster than others, and one of them is image-based data, which is all this convolution neural network stuff, and the other one is language-based data, which is NLP and things like this. So there are these areas which are developing very fast, and they're developing very well. And then there is a reinforcement learning, which is also being developed by the likes of Google and Microsoft and so on. So I think that the whole point about, I guess even that's why I caveated this discussion we had regarding algorithms, because the problem is that today if I wanted to do a classifier, or most people would use something called XGBoost, which is one of the hottest classifier algorithms around. Not exactly easy to explain it, but if you understand what I'm sort of explaining to you now, you could be able to learn it from there. And it's used by Kaggle competitions, it's used by banks, it's used by a number of people. But it's a very relatively recent algorithm. So this is the point about these things, that these things are evolving very fast. And when you want to understand the basics, you basically understand the core algorithm within that. Okay, good. So now I will come back on this and share another set of slides. This set of slides I have shared before, and I will close my slides first. By the way, I will give you a break in about half an hour. So I think we have covered. So as usual, we'll go up to 2 hours, and then Aisha will take over. So I will go up to 5 o'clock UK time, and then Aisha will take over from there. And but after half an hour, I will give you a 10-minute break. Again, I think those breaks are quite important to keep the flow going within there. So this set of slides which I'm sharing with you now, I have shared with you in the resources channel. And let me go back here and go to this Google thing again. So many different platforms that you kind of lose how to share these things with there. Okay. Okay. So this is what I want to discuss with you now. It's a relatively short slide deck, but it has got some ideas which are quite complicated, because mainly because you wouldn't have heard of them before traditionally. The first one is the idea of deterministic versus stochastic. So the idea of deterministic is that if you, for example, had a problem like trying to convert a temperature from Celsius to Fahrenheit, there is only one way to do it, correct? Because there is a standard formula, and the formula works in all the cases. And that's what you want to do. But a machine learning or a deep learning algorithm is typically stochastic. The word stochastic means that it is affected by randomness. And if you look at this diagram here, what you have on the screen, so on the left hand side is a pattern. On the right hand side is these graphs. But what I'm trying to show you is the blue line on the right hand side is the underlying pattern of of the other lines. So it's like if you look at the green, if you look at the purple, and so on and so forth, what if I kind of average it out, trying to find an underlying pattern beneath that, then you get the blue line, correct? So this is the meaning of the word stochastic. The word stochastic means that it is not fixed, or it is affected by randomness. So all of those lines, squiggly lines in the right hand side, are tending to effectively be random distribution to something, but your goal is to find out the underlying pattern behind that randomness. So this is the whole point, and this is why all these algorithms are effectively probabilistic. They're never 100% accurate. This is another example of a stochastic process. So what you're trying to do is, these two lines are similar. There is a clear pattern between them. You're trying to find out a pattern between that. So in all cases, the problem is that you want to map something from domain X to domain Y. And this is something I discussed with you before, was that you have a function or a hidden function, which is what you're trying to find. Although mathematically, this is what you're trying to do. Everything is a function. A deep learning neural network is a function, the CD is a function, the linear regression is a function, or the classification is a function. The difference in all these functions is that they're all driven by data. So these functions are not like your temperature to uh, Celsius to Fahrenheit conversion, because these functions depend on data to give you an accurate response. And I explained to you this example before as well, because the left-hand side is very easy to understand from a high school level. The right-hand side is a function which does not have a known pattern. And the way you understand the pattern is trying to understand the data which was for that function. Okay, so now we come to the brain and the neurons. And like we said, this is how neurons look. And obviously, the neural network doesn't look anything like this. And the neural network looks like this, correct? And of course, the question is, why doesn't it look like that? Because in this case, the neurons in the brain are connected to every other neuron in the brain. And that model is basically non-computable, meaning that it requires so much computation, but we do not have this computation at the moment. And there are some developments like quantum and so on and so forth, which will help this complicated computation, but traditionally that's not the case. So what you then have is effectively a simplification, and this actually computes, and this is what people are trying to do. And what you have is, you have this series of neural networks in series of layers, and each layer is connected to other previous ones, and so on and so forth, and this is what you're trying to do with it. So how does that work? This works in a simple way, that you have hidden input data, you have hidden layers, and you have an output data. And the output data represents something, whether it's a cat or a dog or something like that. And when you see the input data, you see lots of examples of dogs and lots of examples of cats. And the neural network is such that each neuron in a given layer is connected to every neuron in the previous layer. And this is what you end up doing with that. And this is what you have to sort of work with that. So what happens in an image is something slightly different, but you can still look at an image in the same way. Yes, you can take the hidden image, you can encode low level features, and each of the things are sort of creating features as it goes along. The highest layers have certain features, and you can show them within them. So that's generally the way you would work with images. Now, the basic mechanism of a neural network is a feedback loop. And the way it works is that you have an input, you have some form of controller or manipulator, and you have an output, and you are giving the feedback element to train the neural network. And the way you do that is using an algorithm called backpropagation and gradient descent, which we haven't talked to you about before, and I don't think I would have enough time to talk to you much about that. But at the moment, what you have to take it for granted is that that's how you train a neural network. That's what's happening behind the Python code, which you see from there. And what it does is effectively adjust the weights of the neural network. So what I saw, what we showed you here, was each of those neural networks. Okay, we'll come back to the weights and the biases with that, but each of those neurons have a certain amount of weight, and and numbers, and the neural network, when it is trained through gradient descent and backpropagation, effectively changes those weights and biases such that the output is tuned to a particular problem. Now, a bit of mathematics, but if you think about a neuron, let me show you. Let me try to see if I got a picture of a neuron. Okay, maybe I go back to the previous one. If you look at a neuron here, so the way a neuron works is that it has input things which feed as inputs to the neuron, and if it fires beyond a certain level of signal, correct? So if you have a large number of inputs into the neuron which are in a certain direction, then the neuron fires or activates with that signal. So the same idea is basically copied in the neural network as well. So in a neural network, at every neuron, you have a summation of W1x1, W2x2, and so on and so forth. And that then gives you a particular, you sum the inputs, then you apply a function called activation function, and on that you apply the output. And what you then have is that you want to train the algorithm using something called backpropagation and gradient descent. And the way that works is effectively a chain rule. I don't know how much of mathematics you remember, but a chain rule is basically a way to solve nested functions. And a nested function is because every layer of a neural network is basically a function within a function. So for example, this is the outermost function, the one in green, and encapsulated within that is the one in blue, and so on. So the deeper you have, the more neural networks, the more functions you have. And therefore, what you then have is something which is function within a function within a function. And the way you solve that mathematically is using it's called the chain rule. This is the basic maths behind it and the algorithm behind it, which I won't go into much more detail. But if you wanted to understand this, then that's how you would understand it. That's what you would have to do, because the neural network is basically a nested function, and the way you represent a nested function is using a chain rule, and the way you solve the chain rule is basically chain rule is partial differentiation, and the backpropagation gradient descent effectively attribute the different uh, the sort of the error across the neural network using partial derivatives. So again, I won't go much deeper into this particular topic from this point onwards, but that's just to let you know that that's how a neural network is trained. And so what happens here is that every neural network has this sort of every neuron has this sort of a thing where you have your inputs and you have your weights and your biases and your activation function, and based on that you have an output. And if you have enough, so the weight of a signal represents its value. So the higher the weight, the more significance you give to the particular input. And that's just kind of a normal way of looking at it. But beyond the point, if the weights go beyond a certain point, then they get triggered and they activate the neuron within that. So why do we bother with this? The reason, as I said to you, is this thing with nonlinear and linear problems. This was the question that a few people have been asking before. And the reason I didn't go into that is because I would have to explain far more things to you, even at a regression level. But the point is that most problems can be translated into linear separations or can be transformed into a linear problem, even if they are not fully linear. And this is the bit which I said to Shreya's question that we will cover later on if we have time, partly because within 8 weeks I cannot cover much of that. So we are covering the basic regression, the classification, and so on and so forth. So non-linear regression is not a traditional form of regression. However, the idea with nonlinear regression has to do with the fact that you can transform a non-linear signal to a linear signal, which we will come back to. But generally, if you have a linear classifier and non-linear classifier, those are the two examples of that, as you can see on the screen. A linear classifier is the one on the left, non-linear classifier is the one on the right. And you can see that there is a separation, but it is not linear. And so your goal now is to find out this function. Now, we talked about model training and tuning before, and I said to you that the parameters of a model are the ones the model learns from the data, correct? So a model has certain parameters, and those parameters it learns from the data, and that is what model training does. There is another set of parameters called hyperparameters, and they tend to be the ones which are not common to a particular data set. So for example, the number of layers in a neural network is a hyperparameter, because this is independent of the number, is not derived from the data. So the reason why I'm showing you like this is because then you can look at the whole algorithm as a set of the hyperparameters are superset of the model training. So this is the point about, and that's what I wanted to show you, because that's what Aisha will cover with you in the grid search and so on and so forth. So when you try to find hyperparameters of something, you effectively try to sort of look into other techniques of doing that. So these are examples of hyperparameters. So for example, if you have a neural network, there are certain things like learning rate, dropout rate, batch size, etc. And those have to be set or tuned, depends on the problem. And that's why you need to do those steps which we talked about within there. And the model design effectively involves sort of tuning both your parameters and your hyperparameters, because your parameters are ones you sort of get from your data. The hyperparameters is the one you get from the sort of setting them up within the right size within that. So the way you would look at the world is like this. So you have effectively the feature extraction, and then you have your model, and then you have hyperparameters which sit on top of that, and that is what you're trying to do. So what you then end up is something like this. Now, this is the same thing which I've been building up right from the beginning. If you look at the sort of the pipeline flow which I've been trying to do, but now I've added hyperparameters to it. So you do the feature engineering, then you do the model building and hyperparameter together, and then you get the test results and you compare from there. And that's what you would end up doing. So you end up sort of tuning the hyperparameters first and tuning the weights and trying to get your score, and you combine this particular thing together until you get the results from there. Okay, so I will take some questions now with this, because this is quite a complicated set of ideas, and maybe after 15 minutes we can have a break with this. So any questions on this so far? So Shreya, yeah.
Yeah, so last time Ashley she has shown us whether it is like what parameters we need to tune in, what could be the parameters values it could be. So the same way this hyperparameter also works, or is it like our applying our own thing, like on our own experience we should tune it?
No, there is a technique for doing that, and again we'll be covering that in the session in the afternoon with Aisha. And so basically there are some ways in which you cover them, like grid search and things like this. So the thing is, you don't set them yourself. That's the point. I mean, but they are set outside of the data from which to come. It is better to sort of see it in the code and then go with that. So that's how. So okay, yeah. So that's the same question from Shaurya as well. So how do you tune hyperparameters using grid search and things like this? We'll see in the code from there. So Priyanjan, are the today's slides? Yes, they are, and they are always in the resources channel. So I'm answering Priyanjan's question. So they are in the resources channel. They are shared with that. So we always share in the resources channel, not in the main one. So definitely share with that. If you have a problem, let me know. But I hope that answers your question, Shreya. So basically, is going to be covered into this one, into the next session. But yes, we don't have to set them up. You have to use a certain function to set them up. That's the short answer. So how is the activation function selected? So the activation function is not explicitly selected. it comes along with certain parameters which we are going to set. So we haven't done any deep learning so far. Once we see the questions, when we see deep learning, you will come to know from there. This is from Ridwan, the question with that. So again, we'll see it in the code from there. So John, I believe that there has been some work on auto hyperparameter genetic algorithm. Oh, yeah, this is right. So this again brings up to the other question with that. So this is a comment from John. So that's where the world is leading to, that people are trying to automate this process of hyperparameter tuning, and that's what automated machine learning does. Um, whether they use genetic algorithms or not, I'm not sure. They use a number of techniques, but the general idea is that these things are automatically done for you, as opposed to you doing them yourself within there. So that's the sort of answer to that question from
Hi,
John.
Ajit.
Yeah.
Yeah, so you mentioned that backpropagation, right? And that backpropagation gradient descent, there's something called as a loss function, right? In some cases, the loss function is a bit complicated. So like the cross entropy and stuff. So on what basis do we decide what should be the loss function? Is that also one of the hyperparameters or something?
No, so loss function is not a hyperparameter, and it is decided by the algorithm on which you choose to work on. So every algorithm effectively is a set of mathematics along with some code, which is developed as a part of the implementation of the algorithm. So when we are using a particular algorithm, so for example, we are using multi-layer perceptrons, or we are using convolutional neural networks, and so on and so forth. So the way that algorithm has been coded has got the loss function and the things determined within it. So we are not determining it, but it is determined already for us by the choice of the algorithm. That's my sort of answer to that. Yeah. Cool.
Okay, thanks, Ajit.
Hope that up. Thank you. Yeah. So Shreya, does crypto use hyperparameters? So crypto, I think you mean crypto as in cryptography, yes? Correct? Yes, I think you mean cryptography as in security. Um, so the short answer is they are different areas. So cryptography uses a number of deep learning techniques, some of which might use hyperparameters, obviously, but it is not the key thing with that, because what I'm trying to say, every deep learning algorithm or every machine learning algorithm has got some hyperparameters which are involved into them. So that's the answer to that. But it's a tangential question. That's what I'm trying to say with that. Okay, cool. So any more questions on this so far? Okay, so I don't see any questions. So okay, yeah. Ridwan, yeah. How does the depth and the width of a neural net affect the model performance? Yeah, that's a good question. So the thing is, it's always a trade-off between what you want to achieve and what is computationally feasible. So the way a neural network works is that the general rule of the thumb is the more complicated the representation is, the deeper the neural network you need. So more hierarchical features you have, the more deeper the neural network you need to solve the problem. Now, there is no fixed way to determine what the depth and the width of the neural network is. So what people do is they start off with something and they continue to tune it or increase it until they get an optimal sort of an answer. So there is no fixed way to define it, but there is effectively a way you learn, or there is a guideline which says that the more complicated or more deeper a neural network is, the more layers it needs to fix it. So that's the general philosophy. But Ridwan's question, the most of it is that it is an iterative thing. So people start with a certain number of layers and they see how it goes and improve it from there with that. Cool. So has anybody raised their hand yet? No, I think that's the case. That's so far. Okay, so Saif, what steps can be, okay, Prashant, so Saif, what steps can be taken to make neural networks sustainable? So when you say sustainable, in what sense? Saif. Okay, maybe you will type something, or I don't know sure you can unmute yourself or not, but yeah, but let me know what you mean as sustainable. I mean, environment compute sustainable. Yeah. So again, it's a little bit of a trial and error situation. Remember that none of these techniques are used exactly as designed. So for example, when I talk about natural language processing, or when I talk about image-based data, most of them will actually end up using a pre-trained model, which is a transfer learning situation. So you start off with a pre-trained model, which has got like some layers built in already, and then you use that to create something else. So it's not as if you're starting from scratch with that. So there is no sort of a guideline with it, but there is a wider issue around the sustainability of neural networks, partly because they tend to sort of attract a lot of attention in terms of the compute power which is being used, and that discussion is mostly on the pre-trained models with that so far. Okay, good. So Nitin, other approach you can start will less optimal data. Okay, that's fine. That's a comment. The compute. Okay, so Prashant has raised his hand. Yeah.
Yeah, you can hear me. Yeah, so
Yes.
yeah, actually, for the clear idea of hyperparameter tuning, so can you give 2, 3 more examples? And as per my understanding, so hyperparameter tuning means once we provide some raw data and we apply some algorithm or we train that data, so that is the result. Then we again modify the parameter to pass to the program, something like that.
Yeah, this is better if you see it in the code. It's not easy to explain it just in terms of that. That's exactly why I wanted to cover it at least now, so that you see it in the code, and hopefully you will practice it and come back with that. So we are hoping you will spend some time working on the code this week
Okay.
and come back to us with more questions relating to the code and trying it out from there. So this is our objective for this week, because now we have sort of expanded quite a bit of the course going forward, and again we're sticking to very few notebooks, although there is a lot of complexity in those notebooks. But by this time I'm hoping that next time we would have tried it out and come back with code questions relating to that. So hopefully
Okay,
we can
we'll try
work
that.
it like that. Okay, thanks. Yes. Okay, good. So we're almost coming to the break time now. Has anybody else raised their hand? No, I think that's fine so far. Yeah. So we'll take a break now. We'll take a 15-minute break, and then we'll back around 4:30. And then I have about half an hour before I hand over to Aishi at 5 o'clock. And then we will continue with that. Okay, so we have a 15-minute break now. We'll back at 4:30 UK time, which is slightly more than 15 minutes. But yeah, good. Okay, perfect.
Thanks, Ajit.
Thank you. Yeah. Hello, everybody. Welcome back. So now we're going to start next 30 minutes before Aisha. Yes, I think Aisha will join us at 5 o'clock our time. So I think that that's the plan, and I just want to cover some more things with that. And the main thing is that, again, we will look at the scikit-learn notebooks, and we will look at the regression notebook from the perspective of the things which we now know. That's why I sort of introduced to them to step by step, because it's the same code, but we are looking at different parts of it into a bit more detail. And when you go to the classification, we'll do the same thing, and some of it will be similar, and that's what helps you in that regard. So that's generally the way we kind of want to approach the problem. And then we go to the deep learning, where you sort of look at some of these ideas like deep learning neural networks and so on and so forth, and the back propagation and things like this. They will be manifested in the code for that. So that's the plan, and that's why we have these 4 notebooks, which is the sort of regression, classification, and then multi-layer perceptrons, CNN, and the supporting notebooks, which is the pandas, numpy, matplotlib, and scikit-learn. And that basically covers the whole course, and that's why it is sort of structured in that way. And we kind of building it up slowly so that we kind of fill in those gaps as we go along. And so now we are going to cover the point about so about just continuing on from where I left off before, was to do with let me just see if I'm sharing my screen or not. I don't think I am. Let me just check this. It has stopped your sharing, so I'll share again. Okay, so this was what I was sharing before. Yes, and I will share from the I'll start from the beginning just to recap what we were talking about. Just to recap this thing that I talked to you about stochastic algorithms. I said to you that the go to find out things which are stochastic, I had to have a hidden pattern. And then I also said to you that we're going to try to find out a function which maps two things, and everything from a regression to deep learning neural network is a function. And in some cases, the function is simple because it's just a linear straight line. In some cases, it's far more complicated, as this thing on the right hand side. But the end goal is to find a mapping between your x and the y within there. And then we looked at the neural networks, and we started off with the working of the brain. And we talked about this idea in a neuron, which so that you have inputs to the neuron and they fire off beyond a certain level of activation. And this translates to what is called a deep learning neural network, which has a series of neurons arranged in groups, in layers, and each of those layers are connected to the previous layer. And in doing so, there is a certain level of activation functions and weights and so on, which trigger each of those neurons. Depends on the inputs and the weights, on the strength of the inputs and the weights. And this is how you structure this. So the process of training such a neural network basically involves the process of changing the weights and the biases such that they are able to detect a particular problem. For example, if it's a cat, detection of a cat, then that is what a neural network is trained to do. And to do that, you have to show it lots of pictures of cats or dogs or things like this, and such that it is trained so that it is able to, its weights and biases are tuned in such a way that it can detect pictures of cats, dogs. And this is generally what you do. You feed it these images so that it can detect whatever you want to detect, and it is tuned in that way. Images work in a similar way, but there are some complications with that, and those are we will come to when we talk about convolutional neural networks. But for now, assume that they also work in a much more similar sort of a structure within that. And the whole thing in terms of a training a neural network can be looked at as a way of kind of understanding your back propagation, understanding a feedback loop. And the way a feedback loop works is that you give it something and you have a controlling element, and you change your inputs based on the feedback. And the way that works in a neural network is that you have gradient descent and back propagation as your feedback mechanisms, and your weights and biases are the things you tune. At every neuron level, you have your summation of your inputs, which is your W1, X1, W2, X2, and so on and so forth. And then you have an activation function, and that error is what you tune every time. And the total error is total loss function, which is applicable to the whole neural network. And that is apportioned to every layer of the neural network using effectively the chain rule. And at each layer, you apply this thing called gradient descent, and you minimize the neural network errors at each layer, and you continue to do so until the layer is tuned for that. So the mathematics behind that is a chain rule, and not something which most people would be familiar with to a large extent, but still for your information within that. So at every neuron, this is what happens. You have your weights and your inputs and your biases, and they tune and activate a particular thing. Now, that's where we were at. Now, the question is, why bother? Sorry, we covered this as well. Why bother doing this? Is because, like I said to you, that much of the world this could be linear and also non-linear problems, and the neural networks are effectively ways to solve sort of non-linear problems. And the way you can think about them in the next stage of complexity is in terms of looking at hyperparameters as a sort of a best tuning parameter set of parameters, within that your parameters. So you're sort of tuning a loop within a loop, and you do the hyperparameters, and each of the hyperparameters you tune your model. And this is what you end up doing. So you end up doing something which is effectively has a certain, the neural network has a certain number of parameters and hyperparameters. And hyperparameters for a neural network include things such as the dropout rate, the learning rate, the batch size, and so on. And you continue to effectively train the neural network until it is sort of identified within that. And this diagram is now where we come to, and this depicts the loop within loop, because what you do is for every of the parameters you have to train the hyperparameters on top of it, and you continue this sort of multiple loop within loop until you tune them appropriately within that. And of course, there is a way to do that in code, and that's what we saw last time, and we'll be seeing it right again now immediately. And that's why I covered this particular subject now before we go down to that, because what I wanted to show you was that that this is really what's happening when the code, when Aisha will talk to you within the scikit-learn notebooks and so on. So the first time when we asked you to do the scikit-learn notebooks, our objective was basically, when you look at those 4 notebooks, the idea was simply that you get a handle of how to work with the code. And from now onwards, we are going to give you some exercises to do. And one of them will be very straightforward. The one which I think Jaokar mentioned was that we want you to use a different algorithm in place of SVR. But also that we will have some exercises in the scikit-learn notebook, which I'm hoping by next week you would have done that. So at this point now, we can we can have you guys do some real code and come back to it, which is why we kind of keep on going back at certain things so that you re-emphasize them. And if you spend the time this week after this session to work on the code and can submit some code by next week, hopefully we will get some sort of traction from there within that. And some of these things are best tried out with code, so you are better off trying these things out within there. Now, outside of that, I think I have a couple of things I have taken note of. One was the transformers, and one was about the nonlinear, sort of understanding more about linear regression, and partly that has to do with the fact that linear regression, or sort of regression in general, is much more complex than what we have seen here. But we do want to keep it within the context because we got only 8 weeks, and I wanted to cover the 2 machine learning and the 2 deep learning algorithms. So depending on how much time I have, I'll come back to the sort of non-linear regression piece from there. Cool. Now we come to the basic idea of what is learning. And the whole point here is that you can understand a lot about algorithms in general by understanding linear regression. And the way it works is because, like I said to you, the process of learning involves finding a function relationship between x and y, and the simplest of them is a linear relationship when the line is when the relationship is represented by a straight line. That is the equation of the straight line is y equals to mx plus c. This is depicted in this way. And that can be depicted again in this way. This is the whole point about stochastic algorithms, so that you are trying to find out a common line which fits the best to the points. And when I say the word fits, it means that if you look at the error between each point and that line, then the predicted then the sum of the errors should be minimal, correct? Because if I were able to minimize the sum of all these errors, I would get a line which basically is the blue line in the middle, which represents the best fitting line with that. So that's what is happening when we say the word fit. The word fit, as in a code fit, means that you are able to find out a best line which goes through which represents the points as best as it can, and therefore it's the best fitting line. To a large extent, you will have to work a lot more once you start working on these things. So I'm not sure how many people actually trying out the code, trying out the scikit-learn, and trying out the regression notebook so far, because you start to sort of, if you start to experiment with them and try to understand what they are, they kind of help you to do that. So what is happening when I say to minimize the error here? So what we're trying to do is find the sum of square errors and to minimize them, and to do that you get a mathematical function like that. And that's generally what you do. Now, in deep learning, there is a very specific set of unique challenges. So deep learning is a highly parameterized model. A highly parameterized model is something which, so for example, in the linear regression we saw, there are only two parameters which we are trying to find out from the data, which is m and c. M is the slope, which is the gradient, and c is the offset. Yeah. So when you look at an equation like this, sorry, I think it's here somewhere. So when you look at an equation of a straight line, I mean, in this is a straight line, and in this case, c equals to 0, and therefore it passes to the 0 point. But the point here is that once you have a straight line, you have these two parameters to determine it. They collectively determine the straight line, and the way you do that is through the data. But in a deep learning neural network, there are a very large number of parameters to find out. And that's what makes deep learning very powerful. It also makes it very expensive. So the more parameters you have, the more powerful the network is and the harder it is to tune. So when I say the parameters of a deep learning neural network, you mean the things which we can derive from the data. And therefore, typically, those are the weights and the biases. And those are very large in number, because it is a neural network has many neurons, and those neurons are very deep. And that is what makes neural networks both very powerful and also very expensive, because if you didn't want to do it this way, you wouldn't necessarily do it in that you would necessarily not use a neural network, because the neural network is a very expensive way of doing something. And while it is the sort of things which people are trying to use nowadays, the point about this is that it's not necessarily the only way to do things, and in fact it can be a very expensive way to do things under certain circumstances, as we have seen here with that. And that's what makes neural networks so powerful within that. Okay, so this was what I wanted to cover effectively, and a lot of our work in the second two notebooks will be based on the neural networks, and the first two notebooks are based on classification and regression. So we started the first notebook, which is regression. The second notebook will be classification, and before that we have the other ones such as the scikit-learn and so on, which are sort of not tied to a particular algorithm, but are general functions which are used there, and that's why we need to go back and forth to them to go forward from there. Okay. So any questions on this so far? So we got about 15 minutes before Aisha can take over. I don't know whether Aisha is here or not. But in any case, okay, Somal's got a question. Yes, Somal, yeah.
So one of your slide, it said that it showed as an example when we changed the alpha and the layers parameters, then the accuracy was like 85% and then 80 and then 92. My question is like, do we do this manually, or in the industry are there specific techniques? Like I know grid search CV is used for scikit-learn, but like, are there something like that libraries for TensorFlow as well?
So again, you're kind of getting the answer, but you're sort of looking at the answer in a slightly different way. So scikit-learn is a library which is used. So there are levels of libraries. Yes. So the four core libraries are pandas, numpy, matplotlib, and scikit-learn, correct? And pandas gives you the basic data frame and the serial, which is the basic ways in which you can represent data in a tabular format and a sequential format. Numpy gives you the ability to represent data in a matrix. Matplotlib gives you the ability to plot data, and scikit-learn gives you all these other functions which we have been talking about so far within there. Now, when you come to deep learning, you get other set of libraries like TensorFlow and Keras, which are connected with the problem of deep neural networks, meaning that you have these multi-layer perceptrons, convolutional neural networks, etc., which are not a part of scikit-learn. Therefore, the answer is that when you actually work with deep neural networks, you end up using scikit-learn. Which means you use the same function like grid search and so on and so forth. However, there are different ways to tune a deep learning neural network, because the deep learning neural network has some other parameters which are not a part of the traditional scikit-learn, and those we'll kind of see when we come to the deep learning neural network problems. But so far, so that's generally how you would work with that. So you'd use scikit-learn even when you have a deep learning problem. Something scikit-learn is a library which has got many functions which you will use for that. I hope that answers your question with that.
Can I ask a follow-up question to that?
Yeah, sure. Yeah.
So my question is like grid search CV. I've used grid search CV. I worked on RNN and CNN, both of it. So can I use grid search CV and pass an estimator my Keras? For example, I create an RNN layered network, my sequential model to that as an estimator. Is that possible?
Sorry, can you repeat your question again? What is the question?
To a grid search CV, can I pass as an estimator I pass in like bunch of parameters. Do I pass my Keras model itself to that, or do I just give it a matrix of different parameters, ranges where I wanted to fine tune? I mean, how would it know that my sequential model is the one that it needs to find the parameters for? That's where I'm kind of confused.
Okay, we'll see it in the code anyway. But obviously you see the code right now, which is for linear regression, but hopefully that will be clearer with that. So we'll talk about it when we come to the code. Hopefully that would help. So I can't answer the question right now without sort of explaining it to the code, but hopefully. But if you have done it before, then I think that basically you don't pass the whole model to it. You pass the sort of the thing is, you must remember at what stage this is coming through. Yes, and that's what it is. So essentially it's a tuning of the hyperparameters which relate to a particular model. So by the time you come to that point, you've already selected what your model is, and that's what I was trying to say. But I think that let's look at it in the code, and that would help with that.
Okay, thank you.
So two more people have raised their hand. One is Farid. Yes, yeah.
You mentioned weights and biases. Are you talking about the same thing or are they different?
No, they are different. So weights are so if you look at analogy between, let me just see how the best way to explain this now. So the weights are the ones which come in here, correct? So x1 times y1. So weights are ones you multiply your inputs to, correct? The bias term is the one which adds on to the neural. This is not the best of diagrams to do it, but the concept of the bias is the same as, no, this doesn't have, yeah, this doesn't show the bias. It just kind of said that there is a bias, but it didn't show. So the concept of the bias is the same as what you have here. So if this bias was, if this was y equals to mx plus 2, then the offset, the bias would be the same idea as the linear regression. So the point is that it is a base term which you also input to the neuron, which unfortunately doesn't show it here because all these are x1. So if you had another arrow here from the input side, which were the fixed number called b, that would be the bias for that. And the reason why you need that is because in the absence of a bias, your input it passes through the 0, 0 line, which means that if there is no if all the weights are 0, then there is no output with that. So if you want a minimum output, if there is no weight, then it's like setting the bias term which gives you that. Let me try and see if I can find.
So is it always a y-intercept?
Yes, it is the y-intercept. It's equivalent to the y-intercept. Correct.
Okay,
that's
understood.
Right.
Thank you.
Yeah. Let me try to find it because when I use, yeah, that's right. So the Nitin just said that a bias have an equivalent of interest is exactly what I'm trying to say with that. Let me see. I've stopped sharing now. I will try and see if.
No, I was only confused because the way you explained it, it seemed like you were talking about the same thing, but it's clear now.
Yeah. That's fine. Good. Let me just see if there is any diagram here I can show you with that. Okay, I think I will take. Yeah. So this. Why is it not being seen here? For some reason I can't seem to show this. So typically when you show a bias, I'm just going to upload an image which I just found out literally by Googling on the web. I'm going to upload it in the chat. That way we can show what a bias looks like. So now this, I'm going to upload this image here. I'm going to go back here. I'm going to go to the chat. And in the chat, I can't upload an image in a chat. It's not very good. I thought I could do that. Let me do this in my slide then. Let me go in here and I can share this with you. I will just. Just a minute. Okay, so now I will share my screen again, and I will start to share this from here. So I've added a diagram onto the screen because I was not able to. So do you see this diagram now?
Yeah.
Yeah. So basically, that's what a bias would look like. So it is a bias value which would fit into the summation with the weights, and it is basically an offset. So it provides you the same thing as you see here. But in this case, offset is 0, and therefore it passes the 0, 0 line. So when you actually tune, therefore, all these neural networks, you end up trying to find out values of all these weights and biases in a neural network, and this is what makes a neural network quite complex within there. Okay, cool. So I think there were some more questions. Let me just go back here because I heard some noise with it. Is anybody else raising their hand or not? I don't see this at the moment. So I don't know whether this was from here or not. No, and I think this is fine for now. I share you online.
Yes, I'm here.
Okay, good. Okay, then Aisha, we're going to hand over to you now. And the point is that what we want to do is show a little bit of the scikit-learn and explain some of the concepts within that. And Aisha had some more resources which she also shared with you in the resources channel. So that will also help you with that. And then we will ask you to play around with that a little bit and give you about 20 minutes or 30 minutes. And then Aisha will come back and we will answer those questions from there. So the point here is that in those 20-30 minutes, I think it is good that you experiment yourself and try to find out before you come back with that, because that is what we want to do. We want to get you to kind of look into that. And Aisha, one of the exercises I think we can give them this week is that instead of SVR, we can ask them to write the code in linear regression. Yes?
For the classification or sorry, for which model? For the scikit-learn or?
No, for regression. For next week, we can, because at the moment the code is doing SPR, yes, support vector regression, correct?
Oh yes, for the regression notebook. Sorry, I was just thinking for the scikit-learn modulars.
No. For the regression one,
yes.
for the regression one, I'm thinking that maybe we can give them.
Yes.
We can give them an exercise this
Yeah,
week.
that's a good idea.
Yeah, that's a good idea. That's right. Very good. Yeah.
I mean, similarly, I had an example idea for them to give from the scikit-learn notebook, which I will mention.
Yeah, we can give that as well. Yeah. No, it's time they started working now.
Okay.
No, I'm just joking in that way. But I think it's worthwhile having a look at it, because this is the same thing we do at Oxford as well. We kind of give you a good foundation initially and then ask you to do things, because this is the best way to learn. Because even if some of you attempt to do something by next week, I think that's good. So we're going to ask you 2 exercises. The first one is that we're going to ask you to replace SVR by linear regression. And the second one is what Aisha is going to explain to you right now. So there's a question which Shaurya has raised, and then I'm going to hand over to Aisha. Yeah, Shaurya, yeah.
Okay.
Can you please send the notebook link for today's lesson?
Oh, it's there in the resources channel.
No, I can't actually find it. Can you just send it?
Okay, yeah, I will just show it to you now then.
But why can you not find it? I mean, this is what, I mean, if you cannot find that, then next time around you will have struggle. So when you go, do you see the resources channel or not?
Yeah, I'm on the resources channel.
So
are you in Slack? Yes.
Can you see the screen right now?
Okay, maybe I'll stop sharing.
Yeah, I can.
Okay, you can. So today I just made a post and I just say that we're going to recap the regression notebook, and I gave a link also here. This is the same link which we shared before, and the scikit-learn link is here. This is the same notebook also we shared you earlier in the first week. So you can finish from there.
Yeah, but look at the top top of the column there, and that it shows you resources. Yes. So
Yeah.
that's
Yeah.
the channel in Slack, which
Yeah.
is, yeah, that's right. What Aisha is
Yes, yeah.
pointing it out. That's where you want to be, because that's where we post all the things in there. And that's why we want you to make sure that you can see it, because that's where we will always continue to post. In fact, all the things I've posted, including links to the videos, are also from there.
Mhm.
Very good. Okay. So thank you very
Thank
much.
you.
So I'll hand over to Aisha now.
Okay. So here in my post also, I gave you some links. I think they will be useful. I would suggest you to go through them. And for example, here in the scikit-learn, there is a tutorial and it talks about the introduction to machine learning with scikit-learn. As we mentioned earlier, like it explains the problem setting and then how to load the data set and explore the data set. And it continues like the learning and predicting, like how to train the model at the creating the baseline model and make a prediction. And this sort of things you can find out from the resources, and which we are covering in the notebooks as well. And let me just start. So as a recap for the regression problem, what we did last week, we explored the data set. We load and explore the data set. I'm not going to run through. I'm just quickly explain to you. And then here we load the data set and we look at what are the features, what are the input values and the target values. And then we did plotting to understand the data. And then in the pre-processes section, we wanted to remove outliers. In this case, we say that if there is any non-values in the input values, let's remove that and let's train the model based on that. And before training also, we look at the standard scalar function, which rescale all the data in the sum range. And then we created the R baseline model, which is the SVR model. And this is our baseline model, and we are training the model. And then we use the evaluation metrics to evaluate the other model performance. And then we wanted to improve the model. To do that, we use the grid search. By using the grid search, because when we are defining the model, we did not define any parameters. And by using grid search, we want to check what could be the best parameters for my model. And we found the best parameters, and based on the best parameters, I built my model. And again, for the SVR model, I gave the parameters and I trained the model and evaluated the model. So now, as Ajit said in the beginning of the presentation, now we want you to look for the linear regression function, linear regression model, and take it as a baseline and train the linear regression. So let me linear regression scikit-learn. So just go to the linear regression, and you can also check what kind of parameters you can provide while creating the model. And this could be a reference for you. And define the linear regression model and train it and evaluate it and just compare if it is doing better than SVR model, or if it is, or just check how can you improve the linear regression model by using the grid search. So this is one of your example for the next week. Ajit, do you want to add something for this?
No, not really.
Okay.
I think as you've explained it, pretty much that's
Okay.
what we wanted to do. And one of the points we wanted to make, and Aisha has been showing you many of these links, is that those are the actual manual link. Sorry, the standard documentation links. So we are pointing you out to scikit-learn documentation, and that's where we want you to go, because this, of course, there's lots of very good stuff on the internet as well, but we want you to get habit of finding out reference manuals, finding out reference data, and then trying to apply it into different contexts. And this is the point. Yes, so Taisha, thank you.
Okay.
That's what I want to say.
Okay. So, by the way, don't worry about it. I will explain you, make a summary of what you need to do for this week. So, I'm just telling you now, but if you have any questions regarding what you need to do for the next week, also just let me know. But like I told you, I will summarize in the end of the session and I will post it on the Slack. So if this regression is done, I will jump to the scikit-learn. And this is the same notebook which we have given to which is given to you in the beginning of the workshop. And please look at the other notebooks also, because they are good for the practicing for the NumPy, Pandas, Matplotlib, and because you will be thinking as a complete, it will help you for understanding what is going on or how to explore the data set if you have done the other notebooks as well. And please look at the other notebooks. So let's start the scikit-learn. And today we are not going to cover all the notebook. We're going to cover until this point, rescaling and standardizing, and model evaluation metrics, and classification and regression machine learning algorithms. And let's begin with the importing the data sets. And as you can see, we are importing the two data sets, and one is low breast cancer and the Boston data set, and one is the regression and one is the classification. And in the Boston data set, we are going to try to predict the house price, and in the classification using the breast cancer data set, we're going to predict if it is a cancer or not cancer, so it is 0 or 1. And we are importing the other libraries also, like Pandas and NumPy. And here, first of all, we are loading the classification data set, and we are storing in the class data. And for the breast cancer data set, the input values are class X and the target values are stored as class Y. And we are printing the shapes. And let's look at what are our inputs data set here. So it has the features like the mean radius. So this just prints the first 5 rows of the input values, input data set. The mean radius, mean texture, and it goes on to deal this point. It has many features. And here we are loading the regression data set, which you are familiar with the Boston data set, and Boston X and Boston Y, the way we store the input and target values, and we print out the shapes. And let's look at what was the print for the shape for this. So we have 569 input, 569 to 30. And when we look at here, so we have the 506 rows and the 13 columns, which are the features. And if you want, we can also look at what is the Boston X. And here we have the 506 rows and the 13 columns. These are our features. And the first thing we are doing is we are pre-processing the data. We are checking if we want to rescale or not rescale. And for the rescaling, we have a couple of methods. Last week, we saw the standard scalar. And this week, we're going to look at the min-max scalar and the standard scalar too. And if we want to look at more about the min-max scalar, just 1 second. I would suggest, I also post all these links on the Slack, so you can easily find from there, or you can easily find from typing also. So min-max scalar, what it does, it transform the features by rescaling each feature to a given range. So these are the parameters which we can use by defining the min-max scalar function. And we are giving a range. For example, if the range is 0 to 1, which means that we are rescaling all the input values between 0 to 1, or it could be -1 to 1. And let's go back to scikit-learn. So we imported the min-max scalar. Firstly, we are applying the min-max scalar here only on one feature, which is the texture error. So if we go to the breast cancer dataset, and we are seeing the texture error feature here, so we are going to apply the min-max scalar only on the texture error. And what is the range we are giving here? Oh, sorry. Firstly, let's print out the texture error. So here we printed out the first 10 rows of the feature, like these are the first row of the texture error, and we printed out the shape as well. As you can see, we need a two-dimensional data. That's the reason we are reshaping it, and by using the feature values and reshape. And now it is in the two-dimensional tuple, and now we can apply the min-max scalar function within a range, like we want to rescale all the input values between 0 to 1. So this is the range we are giving, and we are applying. Then in the end, we are printing the scaled feature for the first 10 rows. So as you can see, and here I also added the feature. So this was the before rescaling. It has, of course, this is only for the 10 rows, and it has 0, 1.5, 1.3, and now it is transformed, it is rescaled between the 0 to 1, and all the values are rescaled between 0 to 1. Like I told you, here we apply the min-max scalar only on one feature, but you can apply for all the data sets also. And let's look at the standard scalar. And so what we are doing here is, here we will use the standard scalar and we will apply it on all the data set. And before applying the standard scalar, let's firstly check what is the mean and the standard deviation of the inputs. And let's call the data frame. So let's print out our original data as well. So this was our original data set, the breast cancer data set. And here we only thing we did is we take the mean of the median radius feature and we printed the mean of the mean radius. And the same way, we took all the values and we calculated the standard deviation and printed here. This is just, we are showing the mean and standard deviation for all the feature. And let's apply the standard scalar function. And just to show you more about the standard scalar, and if you want also, you can click on source here if you are curious about how it is implemented, and you can read through and have a look at the source code of the standard scalar function, how the calculation is happening. So let's go back. And let's go back to scikit-learn. And we created a scalar variable, and we are applying the standard scalar on all the data set. And then we are printing this transform features for the 10 rows. And let's take a look at the transform data. And here, now you can see the standard deviation is 1, and it is also calculated, the mean also is calculated based on the standard scalar function. Before that, our mean and the standard deviation is calculated, and here after transform the data. And in this section today, I will expect you to apply a normalizer function on the Boston data set, because here we applied min max and the standard scalar function on the breast cancer data set. And in this section, we are asking you to apply, could be one normalizer function. I mean, you can choose min max, standard scalar, or you can do both and try. And you can select one feature, or you can select all the data set and apply the normalizer function on the Boston data set. So this is one thing you will do today. But before that, let's have a look at the model evaluation and the metrics section. So firstly, what we need to do is, before the training, we need to split the data set to train and the test, so that we can evaluate our model, trained model on the unseen data set. And we are using the train and test split and test size. So 70% will be on the training data set and the 30% will be on the test data set. Did I run these codes? Yeah. So let's apply this. And the next thing we are doing is, okay, now we have the training and the test data set. And now we are creating the baseline model. For this case, we are using the dummy classifier. And as a parameter, we are defining the strategy, and uniform and random state is 1. And again, for more detail, and if you want to change the parameters or add more parameters, what you can do is you can go to the scikit-learn and you can check here the parameters. For example, the strategy, it can take the most frequent, prior, stratified, uniform, and constant. If you don't specify any strategy, it will take default as prior. And random state or constant you can define. So what we did here is we take the strategy as uniform and the random state is 1, and we train the model. And then we are getting the score of the trained model. And in the next section, we are introducing here the cross-validation. So what we are doing is, cross-validation is also getting a score for you, but just that based on the defined metric. And now here we will see how we are using and applying the cross-validation. And here we use the dummy classifier and get the score. And let's create a baseline model for the, let's create the logistic regression classifier here as logistic. And as a parameter, we are choosing the liblinear solver. And again, for more detail, and if you want to look at the details, you can come to the scikit-learn and logistic regression, and you can check what kind of parameters you can define here, like penalty, dual, tall-C, and solver. For example, here we define the solver and liblinear, and you can also change this solver to the any other defined parameters. So for this example, we chose the parameter this, and the cross-validation, we need to, so here we have the logistic regression classifier. So we are providing the classifier in the cross-validation function, and we are classifying the input, we are classifying the target values, and we can, we are classifying the CV as 5, and I will just show you what is it. And as a scoring method, we are calling the recall. And let's look at what is cross-validation. So this is the parameters it can take. and estimator, like what we have defined here, logistic and CV. And this will be an integer, and this is a yeah, we will come back to this CV in the next session, but what it does, it creates the false, key mean false, and let's run this. And it gives us a 5 accuracy result. The scoring function is the recall, and we are getting the scoring function. We are getting the score using the cross-validation here. And again, today, what we want is use the cross-validation score and change the scoring to the precision and F1, and just compare the score you are getting. And the second thing is I want you to implement a baseline model. Again, here we use the breast cancer model, and in this exercise, in this section of the exercise, I want you to implement a baseline model and evaluate the use the metrics to evaluate the model on the Boston data set. The same steps, you can also change these evaluation metrics, or you can select any other regression models to implement your baseline model, and just get a score for your trained model. And so let me just summarize. And so one is just apply the normalizer function on the Boston data set. And the second thing is in this exercise section 3, change the cross-validation to precision and F1, and implement a baseline model and do an evaluation for the Boston data set. So now we are giving you 20-30 minutes, and let me know if you have any questions regarding to those.
Yeah, so like Aisha said, we will list all these things to you and put them in the chat, so that if you, I know we won't be able to finish it in 20-30 minutes, but I'm hoping that you will be able to finish it, at least a few of you, by next week. And that's our goal. So our goal for next week is that we want you to complete all of this stuff which Aisha said, which we will list, and also the bit about changing the linear regression algorithm. This was the question which somebody asked already, but I told you at that time that that's an exercise we want you to do. So we'll take one question from Shreya now, and then we'll leave you for 20 minutes before you just test it out and come back with something, and then we will leave you for a week in which hopefully at least some of you would have implemented this in code next week. And next week we will start with the core first, so Aisha first, so that we can understand where you guys are at in terms of doing this. So okay, Shreya, yes.
So I wanted to ask that she has applied for the logistic regression. So I mean, what was the problem that I mean, she thought that she will use that logistic regression?
It's a
What she
classifier,
wanted
so
to
you're
predict,
trying
yeah.
to, yeah, it's a classifier. So I think that was Aisha, that was a cancer data set, isn't it?
Yes, it is a cancer data
Yeah, so
set.
it is cancerous or not. That's the problem, basically.
Okay, but when it's a classifier, so can we go for classification, or we should use for the regression? That actually I'm little bit confused in that two models. That's why I asked.
No, so regression is always to predict the number. Yes, so for example, to predict the stock price or predict the housing price. A classification is in categories. So for example, saying that something is cancerous or not is a classifier, or something is sort of spam or not, that's a classifier. So therefore you're using a classification model, which is a logistic regression. I hope that helps with that.
Yeah, just don't confuse with the name, like if it is a regression, don't confuse with the name. It is a classification model.
Yeah. That's right. That's a very good point with Aisha
Yeah.
said. Although the name of the algorithm is called logistic regression, it is actually a classifier. It's a confusing name, but that's how it is. So it's a classifier. Remember that. Cool. Okay.
Okay,
I hope
and
that answers the question. Yeah.
yeah, and just one question that
Yeah.
why we have not gone for the linear regression and came to a logistic regression?
Because it's a different problem.
Yeah, this is
Because
classification problem. That's the reason.
exactly. It's a
Okay,
classification.
okay.
Okay.
Got
Yeah.
it, got
Yeah,
it, got it.
we were always doing for the breast cancer data set, and we want you to apply all the normalizer function or implement or create a baseline model for the Boston data set, which is the regression problem.
Cool. Okay. Okay, good. Solal, yes.
Yeah, how would you like us to submit our assignments at the end of the week? Do you like us
That's
to
a good
upload
question.
the
I
link?
think, Aisha, we can just ask them to create a notebook, isn't it?
Yes, I think, what's the best way? I'm just thinking. Yes, definitely a notebook. I'm just thinking the submission type. Maybe you can send me an email, or should we take everything?
You
that
can send it as a Slack message, actually.
Okay, yeah, that's a good also, yeah.
Yeah, that
Slack
way
message is
we
better,
interact
yeah.
with that. Yeah, Slack message is better. So what you will have to do is make a copy of the notebook. Basically, that's the best way to do it, isn't it, Aisha?
Yes, definitely, yeah. Just to make a copy and just put your initials for the file name so that I will not get confused with that.
Yeah.
And
And that's the best way to submit it, yeah.
Okay, sure. Thanks.
Yeah, so
And
effectively, you submit to us an IPNYB file,
okay,
which is the notebook file. Yeah.
got it. And can we like, is it okay with you if we send you an email if we have a personal question or something, Professor Jaokar?
Yeah, fine, no problem. Yeah.
Okay, thank you. Is your email address shared anywhere?
I'll share it here now in the chat. Yeah.
Thank you so much.
Yeah, I'll share the Gmail, which is the best. Actually,
Yes.
you should, yeah, because that's the best one to do it. I have an Oxford email address, which I think I will not share here because this is not relating to Oxford.
I think Gmail is fine also.
Yeah,
Let
the
me
Gmail
also
is the best one. Yeah, and Aisha also has an Oxford one, but Aisha will also share you the
let me also
Gmail
my
with
add
that.
my-
Yeah, so Aisha, you can share also your Gmail one here. Yeah,
Thank you. Thank you. I appreciate it both.
no problem. Yeah, thanks. Yeah. So Farid, yes, please. Yeah.
It's a bit off topic, but I tried doing this exercise using a lambda function, and I couldn't get it to work because of compile errors. Have you
When you
seen
say
that?
lambda function, what do you mean by that? I know what a lambda function is, but what exactly you tried here?
Well, I was just trying min-max scalar. So, but there's examples on many examples on YouTube where they do it. When I tried it, I kept getting compile errors. So when I changed it to be a 2D to a 2D tuple, it told me that the apply function wasn't present. It's a bit off topic. Maybe we can discuss it.
Yeah, maybe you can send us an email or
Yeah,
something.
maybe
then we'll
that's a
have
better way of
no
doing it.
worries,
Yeah.
Okay.
I know I can use scikit-learn, but I was just curious as to why it didn't
Yeah,
work.
no problem. That's just fine. Yeah. So okay, I don't think there are any more questions now. Nobody's raised their hand.
I just see one message from Saif on the chat, like I'm getting an error.
Yes, actually,
work,
towards the end, when you are calculating the mean standard transform data, that's where it failed for me. Actually, every other step has gone in successfully, but
Sorry, what is the error? Can you just?
It says, well, it's looking for. It throws out error on the line 5 of the IPython input 16, and
because I don't
syntax
see
error,
your
invalid syntax. So it's trying to pass a parameter to the mean standard transformed function, and I think it is getting some gibberish in that as a data, and that's why it's failing.
Just let me check.
All of the steps have gone in successfully, so I was quite
Sorry.
kind of puzzled
So
that why would it fail here?
Can you see the screen now here?
Yeah.
Which step are you talking? Can you just
So
point out to me?
if you go, that's it. I think that's step number 11, isn't it?
Step
So
number
at the step number 10, you are doing the create scalar.
which scalar? Min-max scale? If you, or maybe it's better if you share your screen so that I can see what.
Well, I'm running between two computers, so I won't be able to share my screen right now. But if you look into your step number 10.
Sorry, step number 10 means like which step number?
Okay, so
it could be
the
different.
first line reads create scalar.
So step number 10 is for me, standardizing rescale. Is that the one?
Hang on a minute. Yes, so that has gone in successfully.
That is gone successfully.
Then you move on to the next step. That has also gone successfully.
Okay, so the class underscore X and this one, right? Okay.
Yeah. Yes, that has gone successfully for me. It's just the step after this.
Yes.
That is where it's failing, actually.
So just can you check what is the difference between your screen and this step?
I don't see any difference, honestly.
And or what is the error? Maybe if it is a syntax, just check everything.
It says it's invalid syntax. Yeah.
For which column?
Call the data frame mean standard transformed, and then it passes a parameter. And I think that's when it passes the parameter, that is where it is failing.
Are you sure it is in?
If you go down further, further of this, yeah, go down further. Keep going down.
Call the data frame. So you are here.
Yeah,
so
yeah. Keep going down.
Here. Oh, this is.
Yeah, this is exactly where it failed.
Okay.
Call the data frame.
So can you just check if how it is written? Maybe there was some syntax here.
Yeah. So to me, it is written as 0 something like it's a special character.
Oh, just make like 0 and 0 to 10. Just
0
delete
10,
that syntax.
I have not changed anything for some reason,
Oh,
anyway, I can edit it. I can try and edit it.
Yeah, sometimes these things happen if you maybe you're running on a different type of
browser. Yeah.
Yeah. Sometimes it's a funny character, but yeah, hopefully it should be fine. You just copy it, paste it.
Yeah, I think it is going through now, actually. So
good.
Yeah, once I change that's fantastic. It's gone through.
Good. Thanks. Good.
Okay.
Good.
Brilliant. Thank you.
Okay, then. So we'll give you some time now. We'll give you about 20 minutes and so on. Then we come back and then we'll take 10 minutes and then we go from there. Okay. Is that okay, Ashley?
Yes, perfectly fine.
Okay, good. So we'll give you 20 minutes. So spend some time in those 20 minutes at that point, and then you can so after 20 minutes we'll take questions. Yes, so this way we'll get a break as well. Aisha and I will get a break as well. But it is good for you to go through it, and then over the next week or so, hopefully some of you would have completed it. As Saif already seems to have made some progress, which is great, Saif. So thank you for that. Okay, all right.
Yeah, the next week, whether I'll reach next week.
Cool. I mean, it's fine. I mean, it's like it's not exact. That's why we're trying to keep it.
No, hopefully.
Yeah, quite keep it flexible and slow as well, because at least if somebody does a little bit, it's okay. I mean, it's like we will still learn from there, right? These things are never easy, and that's our point with that. Very cool. Okay, thanks. We'll be back after 20 minutes, Aisha and I, and then meanwhile you guys will try it out. Okay, so this is not a break for you guys. Yes, okay. For us, it's like we'll just grab something. Okay, see you soon. Aisha, we can start in a couple of minutes.
Yes, I'm here. We can.
Yeah, sure. Yeah. We'll just see what people have to say or any questions they have, kind of stuff.
Yeah.
And then we have only 10 minutes and we wrap up at 6 o'clock.
Okay.
Cool. Yeah. Okay, there's a question already. We'll wait for a couple of minutes before we start taking questions here. Yeah, I was muted. Yeah, we take some questions now. So Shaurya, yes, please. Yeah.
I'm a school student and I'm completely new with these concepts.
Yeah.
So,
I understand, yeah.
can you tell me how I can learn this very easily in deep?
Not really, no. It's not an easy subject, but I know you are a school student. I know your mom, so I think that's how I know. Now, the one thing I would suggest to you is to continue working on it even if you don't understand it fully. And this is a general suggestion to everybody, because data science is such a complicated subject and it builds on so many other subjects and nobody ever understands it completely. All you need to try and do is to try to make sure that you do some things and you understand some of them and you continue working on it. And I think Aisha would give you the same advice as well, because we all start sort of wherever. So Aisha is an industrial engineer, and when she started off, she was attending all these meetups and things like this, and that's how she met me, and that's how I offered her a job at some point. And then we've been working with each other for 4 years now. She's working at Oxford and doing very, very complicated things. The point is that what I'm trying to tell you, and just generally everybody, is that you're never going to know all of it, and this can always be scary to think that you don't know. But once you accept that, then that's what you would like to do. Now, there is an easier way, but I wouldn't recommend it to you. And the easier way is to look at the low code idea. Now, when you're learning, when you're young age, I would recommend you to keep coding. Don't go the low code way, because if you, for example, if you are about in your 40s or if you're 30s and if you're a marketing professional or something like that and didn't have a background of science and engineering, then I would tell you that, okay, look at something like AI Builder or something like that from Microsoft, or a number of these low code applications, which then make it very easy for you because they do all the background work for you. But at your age, I would suggest that you learn coding and then you continue on what you're doing here with this one. I know your mom works with Flutter as well, and I think that's another good platform, to be honest. I mean, that also gives you something tangible you can work on quite quickly. Aisha, maybe you can add something. Yes.
Yeah, I did actually. You say the right thing, and I agree on both of your suggestions. Firstly, how you're studying is you're just diving into all the details, but some point of time, everything starts to relate in your mind. You can look at, for example, any of the any of the examples of the notebooks like Pandas, Matplotlib, because we are using all these libraries as well. So you can just start with one of them. You can take online courses, maybe the short courses. Maybe only just following the notebooks which we provided would help you definitely for a starting point, because, for example, we are covering the notebooks like NumPy, Pandas. So when you want to look more and more detail about those notebooks, you will learn more. For example, scikit-learn may be heavy topic right now, but just try to understand. Maybe watching some videos on the YouTube can help, also taking some online courses or reading books or any the website which is explaining some problem. For example, just take one regression problem and try to understand how they are trying to build that model. I think it helps. But initially it will be hard and you will feel like you don't understand anything, but some point of time everything will start to relate.
Yes, so there's a good suggestion from Aisha. Again, they apply to everybody. I know Shaudia is a school student with that, but I think there's a couple more things with Aisha said I would like to emphasize. The first one is that there are a lot of sources, and sometimes those sources can be quite confusing because there is so many things you can look at on the web. So what we are trying to do is try to give you a very minimalistic but still very detailed approach. So what looks to you like quite complicated is actually quite minimalistic, because that's the minimum number of things you need to know when you're looking at Python. So when I said to you that I will tell you what the scope of the course is, and I won't tell you right at the beginning, that's because I wanted to sort of gauge how much we can cover over 8 weeks. And my sort of analysis, but when I say I, is me and Aisha as well, and also Marina and Kauthar, is that like we look at the core problems, but we go them in a little bit more detail. So rather than just leaving you with scikit-learn, we have come back on session 3 with scikit-learn, because at this point you can see where it applies. Yes, there was a question, I think, from Shreya or somebody on the chat saying that why am I doing this? I think it was the very first week somebody asked this question, and this is a very valid question because you see it and you think, what is this for? I mean, all these things are doing just matrices, and but now you see where it fits in, and this is why we sort of show you something, we see where it fits in, we go back to where it was from. The other point, I think, again, which I thought about while we were speaking, is that to take one problem, again, like Aisha said, it's one problem and explore it into a lot of detail. So if you find something interesting, so people tend to kind of look, maybe you are in school, maybe you have some data set with your school, you can think about some example in your school about exam times, for example, how long did it take you to study or something, or how long did it take your friends to study. You can create a data set based on that, and then on that you can make a prediction with features and so on. So try to find a problem which you relate to, and then work with that problem with data and try to sort of do it from scratch. And this actually is a very, very good way to learn. I mean, because then you start to build data, you try to get your own data, you scrape some data, you ask some interviews and so on and so forth, and try to build it up like that. So I think that those were my 2 suggestions. Hope that's helpful for you, Shaurya. Yep. But in general for everybody, I think, as well with that. So Aisha, do you want to add anything more?
No, Ajit, you
Okay, cool.
summarized
Yeah.
everything.
So I'll take
Thank
some
you.
more questions here from
Thank
here.
you,
I've
Ajit,
got,
sir. I will really try this.
Sure. Thank you very much. Yeah. Thank you. Yeah. So I'll just take some more questions from here. So I've got some questions on the chat here from Dr. Gore. The training example accuracy is 94%. Will this be improved with the increased number of data entries? Yes, in general. Correct. So if you give, the more data you give and the more relevant data it is, the better it improves. But there are various other ways. So the whole improving the accuracy business is a very, how shall we say it? It's a very iterative process. You try it sometimes, you make it work, you try different tuning of parameters, hyperparameters, you try ensembles, like you try other algorithms, and so on and so forth. So the short answer to your question, Dr. Gore, is yes, in general, as a general statement, the more better data you apply, the better it will improve. But there are other ways to improve the accuracy as well. So Nitin's question, both top down and bottom up. Yes, that's fine. So I think that Nitin's just a comment. It's not a question, so that's good. So Vivek, yes, you've raised your hand.
Hi, so my question is, when I changed the scoring function in this exercise from recall to precision or to F1, I get similar numbers, something between 0.9 and 1. So can you please tell me what those scoring functions mean? I mean, what's the difference between recall and precision? And
okay, so those we will come back to in the classification notebook. So those are classification metrics. So we will definitely come back to you with that. But they are ways to evaluate a classifier, basically. And they are, it depends on what what they are applying in what context, and in some cases they would be similar, but the point about them is they are different. So there are certain cases where you sorry, so what I'm trying to say, that if you had an unbalanced data set, for example, you would use a specific type of metric. If you had another type of data set, another problem. So they are not the same across all the data sets. I understand what you have done by changing them, but what I'm trying to tell you is that there is a correlation between the type of problem and the metric you employ. Does that answer your question?
Yeah. Thank
Yeah,
you.
we'll come back to it later on when we do the classification method. So Farid, yes, please. Yeah.
I
Sorry?
was just a bit confused about dummy classifier. Can you
Right.
just give a quick, I know you probably deal with this later, but could you?
Oh, no, that's fine, that's fine. I mean, I know the word dummy classifier is a bit confusing. So if you Google the word, I think it's so basically scikit-learn provides you something called a dummy classifier. Actually, correct me if I'm wrong.
Yes, that's right, Ajit.
Yeah. So scikit-learn provides you something called a dummy classifier. The idea of a dummy classifier is to provide a baseline, and on that baseline, you can improve that classifier. Now, there isn't a need to provide a dummy classifier. You can choose another type of classifier to be your baseline, but it is a function which scikit-learn provides as a baseline, and that's the main reason why it is called there. It is called a dummy classifier to provide a baseline, and this is the whole point of what I've been sort of saying in before as well. The way people actually implement this is that because they don't know which algorithm is the best or something like that, they start with the baseline and try to improve it, which we will also do over time with some other stuff, especially around classification. So this is the meaning of dummy classifier. But
if it's a reference model, what kind of reference model is it? Is it just random data? Or is there something more to it?
Well, a classifier is not, so when I say reference model, I don't mean reference, I mean a baseline. So when I say, so what example, so there was a comment from Dr. Gore which said that we got 94%, yes? So 94% accuracy, yeah? So if you might start off with something and you might get 60% or 70% or something, but that becomes your baseline. Okay, you're going to say that, okay, I'm going to try and improve it from 70% to 80%, 80% to 90%. So you need something to say that, okay, this is where I'm starting from, and that's what I'm going to improve. That's the meaning of a baseline, basically, in machine learning.
I'm sorry if I'm being a bit of a pain, but if we go back to a very simple example, if you have a straight line, the equation's known, y equals mx plus c. Yeah. Are you saying that this dummy classifier is some kind of, I mean, that's where I'm confused.
So that's the regression problem for one thing, yes?
Okay.
Yeah. You agree, yes?
Yeah.
Well, yeah. So when I say dummy classifier, I'm trying to say that you could use, maybe actually we can show it in the code next time. It's easier to show it this in the code. I had my list of things to do with that, because we are using that into multiple places, and we can show it to you definitely with that.
Yeah, I mean, it's difficult to visualize what it is.
Yeah, but my point is, the example you gave was basically a regression problem,
right?
Whereas the classification problem is so I'm just going to add this thing to my list of dummy classifiers here. Dummy classifiers.
But again, it's because there's so much terminology that sometimes
yeah. This is always
confusing.
The case. I totally agree. This is always the case with that, because you have so many things. That is the same example, the same thing I told Shaurya as well. In fact, there is a very much, if you Google this, you will see this quite often. There's something called the imposter syndrome. Yes, so this is something very much applied to data science, because no matter what you do, you feel as if you're not quite up to it, or you haven't done enough with it, and this is a normal feeling. I think people are the most experts in the world, and they wouldn't know something else, because you sort of, there is too much to build on with that. But yeah, so we'll add it to a list of things. Okay, thank you very much. So Sonal, yeah.
So I was doing the linear regression with Boston data. And I did the R square score on that. But then I also tried absolute error and mean squared error. And I'm getting numbers which are not in like the range of 0 to 1. For example, I'm getting for absolute error, I'm getting 3.12. for mean squared 22.7. Can you I know how I mean, I understand what that is. I know what mean absolute error is and mean squared error is. I'm not understanding it in the context of this data, so could you please explain that?
Maybe we will take this question again also offline. But are you saying that you have to change the code, or is it the same code?
No, I changed the. I was working on the exercise as part of the scikit-learn the notebook, where we are asked to do a regression on the Boston data.
Yeah. Yeah, I mean, are you asking what that the result mean?
Yeah, I would like to know, like, are we expecting a number between 0 and 1?
No, we are not expecting the number.
No, we are not. No. That's why I asked you what the question was. But that's good. I mean, that's good. You're trying it out. So send us something if you want to, and we'll have a look at it. But yeah, let's see what other people find also over the next week. With that.
Okay, sure. Thank you.
Good. Yeah. Perfect. Okay, so we have a question from Kanad. Kanad. Yeah.
Okay, sir. I am a newbie in this field. I don't know. I just started learning these things. So I want to know the resources so that I can grab up in the maths.
The maths.
Maths, yes. Because I didn't understand this, standardization. I run it without any errors, but I don't know why I did it. And
yeah. So the maths is a little bit complicated in this case. I have been writing a book on this subject for the last few years. There is a course I run at Oxford, which covers the mathematics of deep learning and machine learning, and it's very popular. But it is not something I can cover in a short duration. I hope I am able to finish this book this year, and hopefully then I can share with it. There are some good resources on the web, and there are some good books on the web as well, but unfortunately they're very complicated. That is a problem, because what you really need is to understand. So in a short, I'll just give you a very quick sort of a 2 5 minute sort of a response to this. So there are 4 things you need to learn for understanding the maths of machine learning and deep learning. They are the probability theory, statistics, linear algebra, and optimization. So optimization is what we have been looking at right now when we look at a machine learning or deep learning sort of algorithm and try to fit how it fits. Yes, because the fitting process is an optimization process mathematically. Similarly, backpropagation and gradient descent are optimization. Probability tells you the sort of randomness in data, which is again what we talked about, stochastic and so on and so forth. And similarly, the statistics tells you the metrics. For example, what Sonal was asking just now, we're looking at these sort of mean square error and things like that. Those become effectively metrics. They come from statistics with that. And then you have the linear algebra. The linear algebra is needed basically because everything becomes a number and a matrix inside an algorithm, and everything is effectively a matrix multiplication or something like that. And that's where those are the 4 foundations, but within that it gets much more complicated. So for example, there is if you look at eigenvectors, so eigenvectors uses some specific maths behind it. If you look at some of the information theory, Shannon's information theory and so on, that's again used somewhere else. So things get very complicated, and it gets much more complicated when you add more like GANs and reinforcement learning and so on. But that's a very short answer to that. But hopefully I don't have a long answer. I have many books, but none of them are basically introductory. That's the problem. They will actually confuse you a little bit. What did you study? What are you doing?
I'm working in a software company.
What did you study? What was your
production engineer?
Okay, so you did a 4-year engineering degree, correct?
Yes.
Okay, then it's not that bad. Basically, then you already know some of the things I talked about. Yes, you in the first 2 years, if you're engineering, almost anywhere in the world, certainly in India, you would have learned some form of, up to your 12th standard, you would have learned some things, but certainly by first year and second year of engineering, you would have learned linear algebra, some statistics, things like that, and then you got to apply them to to this problem, and that's the problem, because that's where it gets more complicated. But I think you would be able to pick it up. Just try to sort of, yeah, we'll have to work through it, but hopefully I'll be able to share more over the year.
Yeah, can you suggest one of the books or something?
uh yeah, I will add this to the list. There was a book, there is a very, very good book, which is called, actually, deep learning. It's called the Deep Learning book. There's a free version of it. There's a very expensive book to own, but there is a free version of it called the Deep Learning book. Although it is called Deep Learning book, it covers machine learning and deep learning, especially the first 4 chapters, first 5 or 6 chapters cover that. There is a PDF version of the book floating around the internet. If you Google Yoshua Bengio.
Is this the one?
Oh yeah,
Oh,
that's
yeah.
right. That's right. So Aisha has found the link. Very good, Aisha. Thank you for that. That's a book I would generally recommend to almost anybody who's interested in this subject. It is a little bit complicated, but it depends on how much maths you are comfortable with. Certainly, the first 5 or 6 chapters, they would cover a lot with that. Then the rest get more and more complicated into deep learning. And there is a PDF version of the book somewhere, which I'm sure you will be able to Google it if you find it somewhere. But that's the book. Basically, Joshua Bengio and Ian Goodfellow. And Joshua Bengio, basically, Ian Goodfellow is the guy who wrote GANs, Generative Adversarial Network. So it's a absolutely static book. So yeah, the Larson and Faber, good. Okay, thank you for that, Nitin. Yes, so I have got a whole bunch of books on math and statistics, which I use. But the thing is, most of them are very complicated, and I wanted to give a kind of a good start to that. Oh yeah, that's good, Priyanjan. Yeah, that's good. So that link which Priyanjan has just shared with you is possibly the best one, because that's a PDF version. I will copy this and put it in the Slack at the moment as resources, so that you will have this accessible. Okay, I will just put it here. I'll just put it as a comment here on Slack, so that you're seeing this, so that because after the chat it disappears. I'll just literally copy and paste it our conversation with that. But yeah, so that's the book I would recommend to anybody who is interested in the maths with it. But I would caution you that sometimes what I don't want people to do is start looking at that and find that it's too complicated and they don't want to pursue that. That isn't the goal of this exercise. So I don't want you to look at it and say that I don't want to do this. I want you to look at it from an exploratory point of view, because you can get away with a lot without knowing that kind of math. So someone like me, I think we use this math because we are Oxford. We are involved in some complicated research projects. So both Aisha and I have been working through Oxford and outside of Oxford. So basically the background is Aisha works for me, so my company, and also we both work at Oxford. So we are working on some things. We are working with a Formula One company, for example, literally starting on Monday. And they are using very complicated things, from aerodynamics to things like that. And you're never going to know that. So that's where you start understanding the maths behind it. But what you're trying to do now, it shouldn't require you to understand too much of these things. I hope that helps. Is it okay?
Yes, and
Yes, thank you very much.
Aisha had also shared a course from edX.
Yeah.
That is there. It is in the general. She had shared it. So
cool.
Yeah, you could look at that too.
Perfect. Thanks. And like I said, on the web, there is no shortage of resources. In many ways, that is part of the problem, because there is so much material out there, it gets extremely confusing. And that's why we are trying to keep it very short as well, so that at least it gives you 8 weeks of achieving something. And then you can kind of explore and go from there. That's the goal of this whole thing in the first place. So yeah, thank you for that, Priyanjan. Very good. Okay.
Yeah, and
Good.
it's like not the dearth of resources, but someone like a real person holding our hand and taking us through. So that's really valuable.
Good. Thank you for that. Very good. Okay, thank you very much. So we see each other on the next Sunday. And again, I will share the video with you now. I think the video has got working. The only comment I would like to make about the video is that the only way I got it working is to make it public. So there is a place on YouTube where you can see it. If anybody has a real problem with that, let me know. I will try to speak to Anand and try to because whatever permission they were giving before, nobody could see it. And I don't know how to fix it. So I told Anand to make it public, but it is not publicized anywhere. So just letting you know that that's the situation with it. Okay. Thank you very much. So we see each other on Sunday. Okay. Aisha, do you want to add anything?
No, I just thank you everyone, and let us know if you have any question. And I also post what you need to do on Slack in the resources group, and you can find out from there which sections and where you need to look at which notebooks.
Okay. Thank you very much. So see each other on Sunday.
Yeah, thank you, Ajit.
Thank you.
Thank you,
Thanks.
sir.
Bye.
Yeah.
Bye. Bye.
Thank you.
Thank you.
Thank you. Bye.
Thank you.